Okay, we'll continue with the Messinian. I will present the DREAM project, which is an umbrella proposal. It's the combination of several proposals. All of them share the same goal, that is drilling in the Mediterranean, drilling the evaporites. Well, by now you all know what is the Messinian salinity crisis. It's a short event starting at 5.9, ending at 5.3, then it's a very short event. It was a catastrophic biological, tectonic, climatic event in the Mediterranean. It was probably the result of the closure of the corridors that were in the Gibraltar Arc system. And the consequence was huge evaporation, probably a major sea level drop, still a controversy about the amplitude of this sea level drop. Huge erosion of the margins, as Marina already mentioned, and a huge precipitation of evaporites, especially in the deep basins, but also in the continental margins and in the onshore basins. It's more than 1 million cubic kilometers of salt. That is around 6% of the total salt in the ocean. And everything ended with the opening of a new strait, probably also in the Gibraltar Arc, maybe the Strait of Gibraltar. Okay, there have been, in the last 40 years after the first discovery of the salt deposits in the middle of the Mediterranean, there have been more than 1,800 papers, most of them in the last 10 years. 50 sites have been drilled in different DSDP, ODP expeditions over the last decades. But still, there are many open questions about the Messinian salinity crisis. Marina already mentioned some of them. Here, we have a list of some of these open questions. One of the most important questions is, most important problems is the chronology, as we already discussed in the first presentation. And especially the correlation between the shallow water and the deep water basins. Well, as this is my field of expertise, I will focus part of my talk on these issues. But there are other questions. For example, one of the problems is the location of the gateways. We know that there were at least North Betic and the South Riffian corridors, but we also know that they were probably closed before the Messinian salinity crisis. Then we don't know now where the water was coming from, supplying all this huge volume of salt. Then we need a connection with the Atlantic, and we don't know where was this connection, where was this strait. Perhaps the Gibraltar Strait is a potential candidate. Okay, there are many questions related with different scenarios about the halite precipitation, gypsum precipitation in the margins, not in the deep basins, all these problems. Also, many questions about life, especially bacteria living in the salt or in different settings. Also, there are many questions about modeling. Okay, I'll start with this sketch. I made it very simple about the correlation between the onshore and the offshore records. Most of what we know about the Messinian salinity crisis come from onshore observations, from outcrops. These observations come from different basins, but normally we refer to this basin as the marginal basins everywhere around the Mediterranean, from Spain, Sicily, Italy in general, Crete, Greece, etc. Well, in most of these basins, we have the pre-evaporitic Messinian. We have two units in the Messinian, what we normally refer as the lower evaporites and the upper evaporites. The upper evaporites are usually evaporites only in the eastern Mediterranean. In the western Mediterranean, we mainly have lagomar deposits. That means freshwater, brackish water, lacustrine deposits. Well, the main difference in these two units is that the lower evaporites is marine. There are many geochemical, there is an agreement on this, some geochemical indications that this is marine evaporites, but the upper evaporites and the lagomar are mainly non-marine? Well, they are separated usually, at least in many of these basins, by an unconformity, Messinian unconformity, one of the Messinian erosive surfaces. And because this unconformity is between the marine and non-marine transition, between the marine and non-marine deposits, we assume that this unconformity is related with the closure of the strait, wherever it was. That was probably the time when this connection with the global ocean stopped. Okay, when in the deep basins, in the west, at least in the western deep basin, it's different in the eastern Mediterranean. The Messinian, as Marina already presented, is usually divided in 3 units. In order to avoid problems with the correlations, Joanna Lofi presented these 3 units as the lower unit, the mobile unit, and the upper unit. Well, this, we have no clue about the age, and we have no clue about the nature, only what we can see from the seismic expression. Well, the mobile unit, everybody assumed that is the salt. Only the top of this, the top part of this upper unit has been drilled in the Western Mediterranean, only the upper 70 meters. Well, this is, I would say, the most established correlation between the onshore and the basins, but there's many potential different correlations. Okay, in general, we assume now, based on, well, sometimes in speculations, but we assume that the 3 units in the deep basin are related with the upper evaporites. Then one of the questions is what happened in the deep sea at the time of deposition of the lower evaporites in the marginal basins. Probably the deep Mediterranean was anoxic, but we don't know. It has never been drilled. The consequence of this huge erosion in the margins during this unconformity, during this erosion here, is that most of this lower evaporite unit was eroded and transported towards the deep sea. And then this is one assumption. The lower unit in the deep sea could be the redeposition of the sediments that were eroded in the continental shelf. Then even if this is evaporitic, it's redeposited gypsum, not primary gypsum. Okay, the salt unit, we know for sure that there should be a connection with the open ocean, but we need a lot of salt to be supplied to the Mediterranean in order to precipitate these huge and thick deposits of salt. Then this should be still, there should be still a marine connection here. That's why we relate these 2 units with this unconformity. Okay, this is one possibility, but there are many others. We still don't know. That's why we need to drill. Okay, let me show you some pictures of the outcrops, especially this one comes from southeast Spain in the Sorbas Basin. Here we can see the pre-evaporitic Mars, which is normally cyclic, alternation between Mars and sapropels and some diatomites. And the first gypsum, the onset of the Messinian salinity crisis, we have the first 2 gypsum cycles here in this outcrop. This is another basin also in the same region in southeast Spain. Again, some very nice cycles in the pre-evaporitic part. And on top of this, we have the onset of the lower evaporites. Well, I was working on this with many others, and we were able to tune these sedimentary cycles to astronomical solutions. That's why we arrived to this age of 5.97 for the onset of the evaporites in this basin and in other basins in the Mediterranean. This is in northern Morocco, again, the pre-evaporitic sediments, and a little bit higher is the onset of the evaporites in northern Morocco. This is the Mesadid section in the Mediterranean. Well, if we continue with the lower evaporites, we have also cycles. You can see here at least 3 of these gypsum cycles. There's alternation between gypsum beds and laminated Mars in between. Then if we assume that this is also the expression of astronomical cycles, then we can get a chronology for the lower evaporites. This is what we more or less already did in the past. Well, this is a detail of the gypsum crystals. Well, if we move to the upper evaporites, or the Lago Mare, here, this is again in southeast Spain. This is a section where in the Lago Mare deposit, we also see cycles like this. This is the alternation between lacustrine, Lago Mare deposits, and fluvial, lacustrine, fluvial. And we can see between 8 and 10 cycles, not only here in Spain, but also in other sections in Italy and other Lago Mare deposits in other regions. Again, same cyclicity. Well, and this is the end of the Messinian story also in Spain. We have the last Lago Mare deposit, and here the Pliocene flooding, the inundation, the Pliocene inundation. The Mayo-Pliocene boundary is here. This is a detail. As you can see here, this is a sharp event. Okay, then I will speak a little bit more about the problems, the chronological problems that we will have in DREAM. Okay, this is the time period of the Messinian salinity crisis between 5.9 and 5.3. This is the astronomical records for this time period. Well, there is no reversal in the magnetic fields during this time period. This is a problem, and we cannot use magnetostratigraphy, at least the classical magnetostratigraphy. There is no reliable microfossil biomarkers so far. Maybe we can find something that we can use for the correlations, but so far there is no biostratigraphy, no potential microfossils. Well, we know it's an interval of 628 kilogears. That means around 28, 29 precession cycles. And we have something else. We have one ash layer, which was dated at 5.5, near the base of the upper evaporites in Italy. Okay, but if we go to the Atlantic side of Spain, we have a continuous marine record in that part. We don't have any salt, any gypsum, just marine deposits. For example, in these two basins, this is the Guadalquivir Basin, and this is the South Riffian Basin. In the Atlantic part, there are continuous marine deposition during the Messinian, from the base of the Messinian to the top. And we have cycles. You can see this, and this is a quarry in near Rabat. We have also some nice cycles in the Mars. And in Spain, in the Guadalquivir Basin, we have also very nice cycles in boreholes. When we drill, or they drill for gas exploration, we have, in this case, inductivity logs or sonic, and there are very nice cycles in these logs. This is Morocco, and this is Spain. And here we have the precession cycles expressed in the logs, and that have been tuned to the astronomical solutions. Then what do we have in the Mediterranean part? Okay, we have the lower evaporites. If we assume that they are related with precession, then starting here at 5.9, we reach an age of 5.61 because we have 16 gypsum cycles. If we do the same for the upper evaporites and we start from here down, there are 8 to 10 cycles, and then we reach this age of 5.5. That means that we still have a gap here, which is probably the time of salt deposition in the deep basins, or the time of this unconformity of this Messinian erosive surface between 5.55 and 5.6. That means that salt was precipitated in a very short time period. This is more or less what we think, but of course, we are not sure if these gypsum cycles in the lower or the upper evaporites are related to precession. This is something that has to be proved. Well, this is a picture of this Messinian or inter-Messinian unconformity Brisighella section in Italy, Vena del Gesso. Here we have the gypsum cycles, the lower evaporites, the erosion here, the lagomare, the upper evaporites here, and the Pliocene on top. Then the unconformity is between the lower and upper evaporites, as I mentioned. But what happened in the Atlantic side of Spain? In particular, what happened in the Guadalquivir Basin again? The records I already showed you are from this part, in the distal part, but more in the eastern part of the basin. This is a seismic record here, east of Sevilla. And we can see again in a kind of intramessinian unconformity, a kind of erosion, a huge incision there. Of course, this is not related to, as maybe the one in the Mediterranean is not related to the sea level drop, or probably is not related. This is something maybe we can discuss with Rob. Probably is not related with the impact that this loading and unloading, the impact of this on the uplift or subsidence, but it's here. And we dated this erosion as late Messinian, probably a very similar age. It's difficult to date an erosion here because, of course, in this part we don't have continuous record. But if we move from here to the western part, it's clearly that this is an intramessinian erosion, probably very close in age to the one that we have seen in the Mediterranean. Okay, going back to the problem of the three units that we have in the deep sea Mediterranean, the lower, mobile, and upper units, then one potential correlation between the Atlantic and the Mediterranean is that the one that I more or less presented. I mean, this is the lower evaporites. Probably during this time period there was anoxic sediments in the deep Mediterranean, but we don't know. And then the lower unit and the mobile unit are probably related with this time period between 5.5 and 5.6, and the upper unit could be related to the upper evaporites. This is one possibility. Well, this could be another one. The lower unit could be equivalent to the lower evaporites. This seems more simple, more logical. Or even this one. This is my favorite hypothesis, that the lower, mobile, and upper unit were all of them a huge evaporitic body of sediment, well, not sediments, a huge evaporitic precipitation taking place just in a very, very short time period. Not only the salt, but also the lower, mobile, and upper unit. Everything, all the evaporitic sediments of the deep basins could fall during this time period. This is something that has to be tested, probably only with drilling. Okay, anyway, all these assumptions are based on a single hypothesis, is that the gypsum cycles, either in the lower or in the upper evaporites, are related with astronomical cycles. There are also some authors that question this, and I think is logical, because we have, so far we have no way to prove. The only proof we have so far is this dating, this astronomical dating of 5.5, that fits more or less with these 10 cycles in the upper evaporites. I think this could be proof also if we have another or other records in the Mediterranean with more ash layers, more volcanic levels intercalated in the lower or upper evaporites. Then we have probably a better dating, and we can more or less check if these cycles are really driven by astronomical changes or not. Okay, then this is something that we need to test or to prove. Well, I'm going back to DREAM, and just in the last part of my talk, just explain more or less what are the targets of this umbrella proposal that as Marina already presented for the Gulf of Lions. The umbrella pre-proposal was submitted in April, uncovering salt giant by Angelo Camerlenghi. Is embracing 4 related scientific drilling proposals. These are the main proposals, or pre-proposals so far. They have to be submitted. Well, this is the proposal more related with the causes and timing and emplacement mechanism of the salt deposits. Is led by Lofi, Joanna Lofi, Camerlenghi, and others. This is more related with salt deformation and fluid flow across the halite layer. It's led by Christian. This is more related with the deep biosphere and the biota, the halophilic bacteria that may live in the salt and below the salt and in these high pressure conditions. Marina already mentioned this. And this is the proposal just presented by Marina mainly in the Gulf of Lions. Okay, Marina already saw this picture. The targets are different sites in different environmental settings. Of course, one target is the deep basins. This is probably the only place where there is no erosion and there is continuous sedimentation during the Messinian. One target is in the deep basin in the Western Mediterranean, the other one in the Eastern Mediterranean. But at the same time, we want to drill also in the intermediate basins. Especially, we target the Balearic promontory for this, and also the continental basins, as we were talking before. This, of course, the different targets need different drilling infrastructures. For the deep basin, we need the CQ because it's the only one that can do this because of the technology, as Rob mentioned before. They have this blowout preventer, which is crucial to drill below the salt or in the salt. For the intermediate basin, maybe JOIDES is good enough, depends on the salt, because in some of these intermediate basins there are also some salt beds, not very thick. And of course, for the continental, we need some other specific platforms. Okay, this is map. This is well, so far we don't need to put all the sizes, just some potential size for these different proposals. One site for sure should be in the Eastern Mediterranean. This region is also very important, the Balearic Islands. The intermediate basins are here and the deep basins in that part, and this is the Gulf of Lions. Well, this is a seismic line of the Eastern Mediterranean. In the Eastern Mediterranean, we have a huge thick sequence of salt, but it has been divided in 6 units, depending on the more transparent or less transparent units. Then the idea is to drill the whole sequence. It's 1,750 meters, and below 650 meters of quaternary. In the Balearic Islands, there are some potential good candidates, some size, also some ICDP for continental drilling in Mallorca. But especially these sites are mainly in the intermediate basins, and this and this, and that is more in the deep basins. This is a seismic line of this site here. Here we also have the upper unit and the mobile unit, and apparently there is a kind of salt in the middle. As far as I know, this has never been published. This is the site here. Is also a very thick upper unit here, also probably with some small salt unit in the middle. Then we don't know exactly if this can be drilled by joiders or not. That's something that the people in the program should say. Okay, as I already explained, in order to accomplish this, we need at least 2 or 3 platforms. For the deep sea drilling, we need the riser drilling. The Chikyu, the Japanese vessel, is the only one that can do this because of this blow preventer. For the intermediate basins, we can do it with the joiders and some mission-specific platforms. I'm almost done. No, I'm done. Well, this is the conclusion, of course, is that we, well, if we can get this proposal to be approved, that could be a good opportunity to understand and to correlate and to solve at least some of the major questions that we still have about the Messinian salinity crisis. Thank you.
Why do you favor the very, very, very thick anoxic? I mean, the position of the lower units into this anoxic period, and the deposition of the I think that the third scenario, the favorite of yours.
Yeah.
How can you explain this amount of salt in such a small time?
Well, salt precipitation is very, very fast. And if you have water coming into the Mediterranean, the precipitation is very, very fast.
But then the evaporation has to be just like a vacuum cleaner, and then, I mean, you really need a huge amount of evaporation in this region.
Well,
I mean, it's a very interesting thing.
I don't, of course, I'm not a specialist on this, but well, even the salt is already very thick. Only the mobile unit is very thick, and well, the best guess is that it could be deposited in less than 60,000 years, probably much less. I don't know about in the mines. Some of the mines, I think, of course, it's very difficult to have any chronology for, but if you go to the salines today, you have.
Yeah, I'm not talking about the ones in I don't know, in yeah, that one, Real Monte or something like that, where you have these 500 meters of salt or even more. But I'm talking, do you also expect that these lower evaporites would have been deposited at that time? I mean.
Well, the main thing, I'm not a specialist, but maybe Marina can comment about this, but if you look at the seismic lines, the lower unit is really, the thickness is really constant. No? I mean, if this is more related with resedimented gypsum, there should be different geometry, different morphology. That's why I think one of the possibilities is that the lower unit is not redeposited gypsum, is not turbidite, it's more evaporated deposit. And it's very thick, I don't know. I mean, if this is related with erosion in the margins, that should be thick, thicker in the margin, but thinner towards the deep basin. But you don't see this in the. And of course, the upper evaporites, they have been drilled in 2 places at least, or 3, I don't remember, and it's evaporitic for sure. And then but the main question is, and then what happened with the Lago Mare? Because we have huge deposits of Lago Mare in the margins. But my guess is that the Lago Mare is a deposit that when the sea level was already high. And then in the middle of the basin, probably there was almost no sedimentation. Well, this is one guess based also on the observations, because in some of the deep sea holes, they found a Lago Mare deposit, but it's very thin. Never hundreds of meters. I don't know, the upper unit is hundreds of meters. No, some 10 meters, 20 meters, but not hundreds.
In fact, in some lines, you can see the detrital deposits with the chaotic body coming from the margin. So this has been mapped also, and then in the deepest you have the lower unit, and then it unlaps onto these deposits. So So in some places you can make some differences between different kinds of geometries, but we really need to go through it to really know if it's only evaporites or a mix between things.
I had another question for you, Paco. Of course, each of these proposed drilling sites are very expensive. So can you elaborate a little bit why, on top of having a site in the Western Mediterranean, what is the urgency of also having an one in the East?
Well, this is more a scientific question. Of course, it increased the budget. It's very, very expensive, as you mentioned. Well, it's just that there is, I mean, you have different lithologies in the East and the West, and just to know what happened. I mean, in the Western Mediterranean, we always have this trilogy, and in the Eastern, you have only one continuous sequence. Well, finally, they describe these 6 units, but it's mainly, I think, as far as I know, it's mainly salt, what they expect to find there, with maybe some intercalations. But, well, yeah, it could be only the Western Mediterranean, but, well, I think if this is more or less approved, they will consider the price, of course.
You want to add to that?
Well, I also understood that, I mean, it's essential to see whether the 3 units in the Western Mediterranean correlate with which one in the Eastern Mediterranean to know what the transfer was between the two. I think this is why it is scientifically important, no? But another reason I understood is also because the GQ is the ship that is expensive to be brought to the Mediterranean, and I heard at some point that it would not come just for a drilling or two. So it needed more work.
We can find more.
Yeah, there's also the interest of oil companies. I mean, of course, the Eastern and the Western Mediterranean, they are very interested in drilling below the salt. And they are already drilling in the Eastern Mediterranean. And then the only way to do this is getting money from these oil companies, because this is going to cost a lot.
You nicely pointed out the problem with correlation between the deep and the shallow. This seems to be one of the biggest problems here. But the problem is the time correlation, not the lithology of those units. Is that not correct? You know what salt, and you know what is underlying the salt, whether presumably some kind of pelagic sediments. But aren't there other places in the Mediterranean where you could do a better job of tracking these through seismic data up onto shore, where we could see what these are? And I'm thinking in particular the Adriatic, which you didn't talk about at all.
The Adriatic.
Yeah, where cause we can identify the same units in the subsurface, but there they eventually come on shore, or at least up into the Po plain where they've been drilled.
Yeah, well, that's one of the main questions with the gold, because of course it's probably the best place to answer all our questions, but it's very expensive. That's why we try to find in the Balearic Islands, but still is an expensive project. In the Adriatic, I don't know now, and we were talking about also the Tyrrhenian Sea, but any basin has its particular problems, and we know more, of course, about the Balearic Islands. There is also a lot of oil exploration in this region, maybe also in the Adriatic, but I'm not sure about this. But there are probably other places, but I think we were checking many with Marina, with, of course, Angelo, Joanna, all the people that has the seismic. I'm not working on seismic, but they were checking different sites and different places. And, well, we finally came up with this Balearic Island and the Gulf of Lions, but of course it's... in the Balearic Islands, there are many boreholes that were drilled already. We have now, we have an ITN working on the Medgate, on the Mediterranean gateways, and one of the PhD students is working on several oil exploration holes in the Balearic Island. And we have a good idea of what happened in the Balearic Island, at least in these sites. But of course, we work with cuttings and not with cores, and then it's also not easy to interpret the evaporitic sediments only based on cuttings. You really need cores and to see the...
And the other, well, just commenting on this, you correct me if I'm wrong, but I understand the other reason is that the Po Basin is thought by many to be partially isolated. It's like a marginal basin, and it might respond completely different than the central Mediterranean basins to the Messinian events. So if you drill there, you may get even more lost than at the beginning.
If you can avoid drilling by correlating these things to the deeper water, because it's fairly continuous.
Some people imagine a seal in between that is keeping a different base level.